Okay, I want you to picture this. You walk out to your driveway in the morning and, there it is, a dark, shiny puddle of oil sitting right under your car. Your very first instinct? Probably to look straight up above that puddle and just start unbolting whatever you see. Well, let me stop you right there, because honestly, that puddle, it's lying to you. Once oil escapes the seal, gravity and airflow completely change its path. We get constantly tricked by where the oil ends up instead of looking for where it actually started. So today, consider this your masterclass in diagnostics and repair. I'm going to teach you how to think, diagnose, and wrench like a true master mechanic. Look, engine oil is literally the lifeblood of your vehicle. It lubricates, it cools, it seals. But when it starts escaping, you're looking at reduced performance, serious fire risks, and honestly, catastrophic engine failure if you just ignore it. So, no more guessing, we're going to start actually fixing. Okay, let's dive into this. Here's our roadmap for the day. First, the anatomy of a leak. Then, pro detection, master repair rules, the hidden culprit, and finally, maintenance and prevention. Let's get into it. Starting off with Section 1, the anatomy of a leak. To fix a problem, we've got to know exactly where that engine lifeblood is escaping from. Think of your engine from top to bottom. Way up at the top, you've got the valve cover gasket sealing the valve train. Move down to the very bottom, there's the oil pan gasket. Then, at the ends of the rotating crankshaft, you have your front and rear main seals. Up front, the timing cover, keeping oil inside the timing mechanisms. And of course, the classics, the oil filter and the drain plug. So why do these fail? Well, it's pretty simple. Endless engine heat cycles and constant vibration cause those rubber seals and gaskets to just lose their elasticity over time. They get brittle, they warp, and eventually they crack. Now, a real master mechanic uses all their senses to identify the signs of seal wear. Let's compare the top and the bottom of the engine. A failing valve cover gasket right at the top will often drip oil directly onto a scorching hot exhaust manifold. The result? You won't even see a puddle on the ground, but you will absolutely smell burning oil. You might even see smoke puffing from the engine bay or get misfires if oil pools up in the spark plug walls. Contrast that with an oil pan gasket leak way down at the bottom of the block. That is where you get those classic driveway puddles and notice your oil levels dropping over a few weeks. But here is a crucial piece of golden shop wisdom, and I really want you to remember this one. Airflow pushes oil backward. Think about it. When you're driving at highway speeds, the wind resistance blasts any leaking oil straight toward the rear of the vehicle. That means if you see a drip hanging off the back of the oil pan, the actual broken seal could be the timing cover all the way at the front of the engine. Crazy, right? You must always trace the oil paths upward and forward from the spot where it's visibly dripping. All right, moving on to Section 2, Pro Detection. It's time to shift gears from just guessing to actual professional detection methods. If you want to isolate a leak like a pro, you follow these exact steps. Step 1, you have got to clean the entire lower engine and transmission with a heavy-duty degreaser. Seriously, you cannot find a fresh leak on an engine that's caked in 5 years of old sludge. Step 2, add a fluorescent UV dye directly into the engine oil. Step 3, drive the vehicle for 15 to 20 minutes at varied RPMs and loads. You want to get that oil pressure up. And Step 4, park the car, grab a UV flashlight, and inspect that engine block in the dark. Now, what's really interesting about this UV dye test is how this brilliantly simple, scientific approach removes literally all the guesswork. Instead of just throwing random parts at a greasy engine hoping something sticks, this test illuminates the exact origin point in bright, glowing yellow or green. It is hands down the definitive way to isolate hard-to-find leaks, especially when you're trying to distinguish between, say, a blown rear main seal and just a slightly weeping oil pan corner. Next up, Section 3, Master Repair Rules. Once we've actually found the leak, we have to fix it correctly, using the non-negotiable laws of the shop. I call this the Rule of 3 for shop repairs. Number 1, cleanliness. You must clean those mating surfaces down to bare metal. But listen, when you're scraping off old gasket material, you really have to develop a physical feel for it so you don't accidentally score the soft aluminum engine block. Number 2, hardware. We always use new hardware. Never, ever reuse old gaskets or crush washers. And number 3, fastening. You must follow a crisscross torque sequence to ensure even gasket compression. If you just tighten bolts in a straight line, you are going to warp the cover. Guaranteed. So the absolutely crucial point here, never reuse a crush washer, ever. I see this all the time, and it's a classic, completely avoidable rookie mistake. An old drain plug uses a small metal washer that literally crushes when tightened. That's what creates a perfect seal. If you do an oil change and put that already flattened washer back on, you are practically guaranteeing a fresh oil leak right at the drain plug. Seriously, it costs less than $1. Just replace it every single time. And while we're on the subject of tightening, keep the number 12 in your head. That represents 12 Newton meters, which is a very standard manufacturer torque specification for an oil pan bolt. Master mechanics, master torque specs. If you just grab a wrench and guess the torque by feel, you're going to over-tighten those bolts. Over-tightening cracks plastic valve covers and unevenly crushes rubber gaskets, which, you guessed it, creates brand new leaks. Always, always use the exact manufacturer torque specifications for your specific engine.
All right, Section 4, the hidden culprit.
Now that you know how to seal the engine up properly, we need to talk about the secret enemy of engine gaskets that most beginners completely overlook. Allow me to introduce you to the PCV system, or positive crankcase ventilation. When your engine runs, tiny amounts of combustion gases blow past the piston rings and build up inside the engine block. The PCV system's job is to safely vent those excessive blow-by gases back into the intake manifold so they can be burned off. And this brilliantly illustrates why understanding the whole system is so vital. A clogged PCV valve means all that excessive crankcase pressure has nowhere to go. It just builds and builds until it physically pushes engine oil right past perfectly good seals. You could replace a valve cover gasket or a camshaft seal 5 times in a row, but if your PCV system is blocked, they'll just blow that brand new seal the second you hit the highway. Always check the PCV system if you're dealing with an engine that has multiple gasket leaks. Which brings us to our final section, number 5, maintenance and prevention. Because let's be real, the best repair is the one you never have to make. But part of being a master is knowing your limits. When should you grab your own wrench, and when do you absolutely need to take it to a pro shop? Things like replacing a valve cover gasket, swapping an oil pressure sensor, or changing a drain plug, those are incredibly DIY-friendly jobs. You just need basic hand tools. However, jobs like the rear main seal or the front timing cover, totally different beasts. A rear main seal leak almost always requires completely separating the heavy transmission from the engine block, so unless you've got heavy-duty engine support tools and a professional lift at home, definitely leave that one to a pro shop. But you can actually prevent a lot of those massive, expensive jobs by sticking to strict, regular maintenance schedules. Regular oil and filter changes are your absolute first line of defense. Using the exact oil viscosity recommended by the manufacturer ensures your oil pressure doesn't randomly spike. Replacing worn PCV hoses keeps that crankcase pressure nicely balanced. And perhaps most importantly, fix small leaks immediately. Do it before that oil contaminates your timing belts or shorts out your alternator. Regular maintenance prevents those rubber seals from losing their elasticity, and it stops major engine failures right in their tracks. Let's move a step further and see how this builds into the engine chemistry. The fluids you choose directly impact the lifespan of your seals. Low-quality oil or old oil that's become super contaminated with engine sludge actually accelerates the chemical breakdown of the gasket material. It's crazy. The constant heat cycles combined with degraded, dirty oil literally eat away at the rubber and silicone from the inside out. Which brings us to our final question for today's explainer. When you look down and see that oil on your driveway, are you just treating the symptom, or are you fixing the root cause? An oil leak is rarely just a random bit of bad luck. It's the result of seal degradation, a pressure imbalance, or an installation error. Correct diagnosis using UV dye, understanding how airflow shifts the evidence, strictly adhering to manufacturer torque specs, and checking systems like the PCV, that is what separates the weekend parts changers from the true master mechanics. So the next time you pick up a wrench, I want you to remember these rules. Find the true root cause and fix it right the first time.